salivary glands in the actual mucosa dotted around. But the three main pairs that do most of the work here are the parotid gland, and that's up here. Otid means next to the ear, so parotid just means it's up there. So they're actually kind of behind and under in there. So when you get a swollen gland back under the corner of your jaw, that's the parotid gland right here. Then there are, and so there'll be a left and right of those. There'll be a left and right of these ones as well. Sublingual means it's under the tongue. So these are the sublingual glands. They have several little ducts going out. And then the submandibular is this lumpy guy here. So those are the ones that you can kind of feel under here. So parotid, submandibular, and sublingual there. So then the teeth, I think they really need no introduction, and they're obviously not going to be a little too much of a given.
We could use all the help we can get.
Well, yeah, if you don't put second incisor and give it its dentistry name, it's a number 7 or something, you know, it's like whatever. No,
I actually
it could be a difficult, what?
I need to know that, so.
It could be a difficult question though. Yeah, one time I had a tooth out and it was like number 19. I tried to figure out, okay, how did they get to 19? Is it, I mean, anyway, I finally just stopped worrying about it. So, actually I kind of did eventually figure out. So anyway, so the tongue, we haven't got the tongue yet. Teeth there, the hard palate. So here's the hard palate, formed by the maxilla and the palatine bones. And so that's the roof of our mouth. And then the soft palate is just the part at the back where there's no bones, where we can push the food with the back of our tongue and it will fall over and down the esophagus. So, does our palate have ridges or rugae? Rugae just means ridges. The answer to that is not really. There's a little bumpiness to it, but a cat's palate, when we would look at the inside of the cat's mouth, it's very pronounced ridges and kind of got a lot of spiky little pieces like on its tongue for, I guess, holding its prey better or something. But we don't really need to trap a struggling mouse in our mouth, hopefully, so we don't need those. So the answer is no, we don't have it. The pharynx, there's actually 3 parts to the pharynx. The nasopharynx is up here behind the nose. The oropharynx is the part where you say ah and the doctor sees your oropharynx. And the laryngopharynx is the little piece in your throat before it divides into the trachea and the esophagus. Obviously, obviously these are not really going to be, the oropharynx isn't something I can really effectively put a label on, and nor is the esophageal opening. So the tongue, again, I'm really not going to, that's not going to be something that I'm going to put one on. So it talks about the different papillae, and in 231 we talked about the fungiform and the circumvallate and all those papillae that have taste buds. The reason I'm mentioning the filiform papillae here is that those ones don't have taste buds, they're more structural. So those are the ones that in a cat, filiform means it's formed like a hair. Those are the ones that in a cat allow it to groom its fur and the cat's tongue feels really rough. We kind of have them, which we have a little bit of bumpiness to our tongue. So if you lick an ice cream cone, you get some ice cream. It doesn't just slide off it like Teflon. But that's what the filiform papillae are. The lingual frenulum, I can show it more easily on myself. That's a little piece that holds my tongue down to the floor of my mouth. The epiglottis, we can't see at all on here, so I'm crunching my cough drop to get rid of it because it's annoying me for talking. The epiglottis is the little flat of cartilage so that when we swallow, it'll cover the larynx and the airway and prevent us from swallowing the wrong way, hopefully. So we did that in the respiratory system. We can't see that here, right? I'm just going through everything that's on here. Esophageal opening, well, it's somewhere down there, but we can't see that as well. So most of those things, other than the salivary glands and a couple of obvious ones like the teeth and tongue and the hard palate and the soft palate, that's pretty much all we can really see on it. So then we go down the esophagus and we enter into the abdominal area, and now we've got some of these others. So the peritoneum. The peritoneum is this cavity here, and so I've got and its membrane, it's associated serous membrane. So I've got the parietal peritoneum, which is lining the cavity, and I've got the visceral peritoneum covering different organs. So they're very thin. They're just a layer of squamous cells with a little bit of either areolar or adipose tissue as a lamina propria for it. So that's the peritoneum. We've got parietal and visceral, and then what they're saying here is there's a few other little pieces of peritoneum-like structures that are kind of extensions of the peritoneum and have their own little names. So for the parietal peritoneum, the only one they're going to include is this little ligament that attaches the liver back against the wall there and kind of forms a division of these two lobes here. And so that's the falciform ligament, that little white bit dividing the liver up and attaching it. The visceral peritoneum, and there's a question in here, what would you consider to be extensions of the visceral peritoneum? So, modification. So the visceral peritoneum itself wouldn't really be an answer to those. We're going to look, there's actually 4 different possibilities to that. There's the greater and lesser omentum. And those are, here's our visceral peritoneum would be the squamous cells and a little bit of fatty tissue here. And if we imagine it keeping going, this would continue over here. They've shown the beginning of it, and if it was really big, it would hang over like a sheet. That's kind of what they're showing here. They didn't show it on this one, but here they showed the greater omentum. So it's kind of providing a little apron of extra padding here. And it's really just attached to and continuous with the visceral peritoneum. The lesser omentum does the same thing. It's much smaller, and it's on the inside curvature of the stomach, hence lesser. They don't even show it here, so obviously that can't be shown. But this would be the greater omentum would be here. And I guess this would be a little bit of it. So those are those two. And then we've got the mesentery and the mesocolon. And to show what that is, we need to see what a mesentery really is. So a mesentery is the webbing that holds the intestine together. And the greater and the small and large intestine each have one. So you can see here, again, the visceral peritoneum would stretch over here and then would be continuous with the mesentery. The mesentery would consist of squamous epithelium on both sides and then some connective tissue. The main purpose of it is to allow vessels to distribute easily. Otherwise, you'd start here and you'd be out of oxygen by the time you got to here. So we're going to distribute and give oxygen to everybody and collect up all the food and whatever, I guess from the large intestine, not much reabsorption. So this would be, remember the greater mesenteric, the superior mesenteric and the inferior mesenteric, and you probably thought, why are they mesenteric? Well, or maybe I showed the mesentery at that time. But this would be the inferior mesenteric artery. It really goes, most of its life it's spent going through the mesentery, and it really just reaches the intestines for sort of the small arterioles. If I could unravel this one, it would show that it's got a webbing like that as well, and the superior mesenteric artery would connect that. So those are what the mesenteries are. So you can kind of see the mesentery here.
Is that just intestines?
Right, so here's all the intestines, and if I could unravel it like this one, I could unravel it so that here would be the intestinal spread out, and then I'd have all the mesentery forming a kind of webbing connecting it. But instead it's all bundled together. And then it would have the blood vessels going through that in the same kind of way. So those are all essentially extensions and modifications of the visceral peritoneum. You can kind of see that it would extend here and continue on there. And, all right, so then we get to the liver. Here's our liver. We already saw the falciform ligament. This is the gallbladder, where bile is made in the liver, and then it's stored in the gallbladder. It actually can be concentrated down for up to as much as 10 times its original strength, and then it gets sent out to the intestines when it's time to have some. So there's liver and gallbladder. The stomach. Now it says the stomach has rugae. Well, not on the outside, but it has them on the inside, and it really does have them. Pretty much every organ that's going to fill up and stretch is going to have some kind of ridging, because the epithelium is going to tear otherwise. So it has to be kind of crinkled up, kind of like when you take off your underwear, the elastic kind of crinkles it up, and then you stretch it out and put it on again. So after Thanksgiving dinner, these would be all stretched out, and then they could crinkle all up again. So the bladder is the same way inside. Anything that's going to go through a lot of expanding and contracting is going to have that ridging effect to allow that to happen. So those are the rugae inside the stomach. The pancreas let's put this back in place so we can see where the pancreas is. So here's the pancreas. So it's mostly an exocrine gland. It's got a few islets of Langerhans for insulin and stuff, but then, so all these ducts are leading into the duodenum right here. So producing both bicarbonate for neutralizing stomach contents and various digestive secretions. So then the small intestine, the first little part, the duodenum here, if we get to put the stomach back together and stick it on there, we can see how it sort of fits together. So stomach, okay, so stomach is here. Came from the esophagus to stomach. The duodenum is receiving the very acid contents. So it needs secretions from the pancreas to neutralize as well as provide digestive juices. It's also getting secretions from the gallbladder. Because of those ducts coming in, it has to be much more rigidly held than the much floppier rest of the small intestine. So the duodenum is kind of a fairly rigid C-shaped little piece, and the rest of the intestines are much floppier. It says it's a jejunum and an ileum, but if we just say ileum, that's fine. The villi are really only seeable inside. Well, no, we can't see villi there. We can see some ridging, but you can't really see individual villi. So then, we go from the small intestine. Here's where the small intestine finishes up. The ileocecal valve is right here. This is the cecum, this little dead end piece. So really most of the large intestine is here. This little blind alley is the cecum, and that's the appendix coming off of it. Although it doesn't say appendix there, but there is the appendix. Then the colon is here. To be technical, we'd have ascending, transverse, and descending colon, and sigmoid colon, but as a whole, the large intestine will be the colon. And then the rectum and anus are down in there and are suitably brown, and we'll let you use your imagination on those. So anyway, so these questions here, I mean, I know I talked about a couple of them, but you know, you can just kind of look. I'm not worried about those questions. That's really not, except for knowing what the mesentery is and what it does. That's really the main thing.
But the large intestine you would call the ileum?
I would call the